if you have to integrate a function f of x raised to the nth power, if it is multiplied by its first derivative, f prime x dx, then we don't have to do that many substitutions or simplifications further. We can straight away write down the answer as f of x raised to the n plus first power all divided by n plus 1. And this can be done when n is not equal to -1. So during the discussion today, I'm going to discuss another example where we can directly apply this theorem. So the example is integral. On the numerator, I have x to the third power. In the denominator, I have the square root 1 minus x to the fourth power dx. Now, typically, the students try this question using substitutions. But of course, we don't need any substitutions to answer this question if you know that previous theorem. That is because we can see this question as integral 1 minus x to the fourth power raised to the -half power, that times x cubed dx. Well, in that case, if we see this part of the function 1 minus x to the fourth as fx and this -half power as n, then all I need is the first derivative of that function fx, 1 minus x to the fourth, for this part, x to the cubed part. But I have only x to the cubed. If I differentiate 1 minus x to the fourth, I'm going to need a 4x cubed, in fact, a -4x cubed. I can create that by writing a -4 here and dividing that by -4, like this. Now, we have f of x, which is 1 minus x to the fourth, and right here is n, which is equal to -1/2, and all of this part is f prime x. Now we can directly apply that theorem and write down the final answer. I have -1/4 outside. F of x is 1 minus x to the fourth. N plus 1. N is equal to -half. Therefore, n plus 1 will be equal to +half, and that divided by +half. And there will be a plus c. This needs to be simplified further. -1/4 divided by 1/2 is equal to -1/2, and 1 minus x to the fourth 1/2 power, which can be written as 1 minus x to the fourth square root and plus c. So that's going to be our final answer for this question. We didn't use any substitution. Alright, hope you enjoyed this example. Thanks.